In this video, I wanted to kind of give you some hints on how to attack some multiple choice questions on polars. This is also going to serve as a quiz for the week, so I'm going to get you started, but I'm not actually going to answer the question. Here I have graphed this. This was a calculator question. I said find the area of the area of the closed region bounded by the polar graph is given by which integral. Well, I always start with this. I say, okay, area in polars is 1/2 r squared d theta. So the first thing I guess I'm going to look for here is I got, area equals 1/2 integral. It should be the square root of 3 plus cosine theta squared, so it should just be 3 plus cosine theta. Okay, so right away start crossing some things out. Okay, now you need the bounds. Well, if I plug in 0, let's say I just plug in, to this, theta equals 0. The cosine of 0 is 1. So when theta is 0, r is 2. So this is this point right here because it's theta is 0 and it's 2 units out. Well, think about what it takes to get back to that point. Okay, because you'll see that none of these ones that are left, or none of these have a 1/2 up front. So what must be being done here is using some symmetry and saying, well, I'll only do half of it, but then I'll double the answer. So you have to figure out what those bounds might be. Again, this is going to be slide 1, and there is going to be a quiz on this, so I'm not going to answer it. I'm going to let you finish this problem up. You could pause here and get your answer down. Maybe use your calculator to make sure your bounds are correct. But figure out A through E which one is the answer. Alright, this is slide number 2, the area of the region enclosed by the polar curve. Well, there we are. Okay, now I've graphed the whole thing. And again, don't forget, area is 1/2 integral of r squared d theta. Now, the beauty of this one is they actually kind of gave you the bounds, but I wanted to just kind of point out, if I plug theta in here, let's start with like a theta of 0. I just always like to know where the graph starts. Well, the sine of 2 times 0, the sine of 0 is 0. So here is that initial position. Okay, so then you start thinking, well, when's the next time it gets back to 0? Well, the sine of pi is 0. So 2 times theta should be pi. So, that saying it goes from 0 to pi over 2 should give us just this one loop. Okay? And again, just kind of tracing my logic here. Remember that the sine of pi is 0. So 2 theta has to be equal to pi in order to get to trace all the way around and get back here. Okay, so that's why this bound of pi over 2 will help us to enclose that one loop. So again, you can use your calculator. This is question 2 on the quiz. Figure out which one it is. Slide 2, answer it.